Okay, let's start. So I'm like, shut the door, please. Well, I'm Mike Zaharee. I'm the team lead for the network stack. Here to tell you about some of the things we got going on. Unfortunately, somebody has spilled most of the beans in his own personal talk. For what gain, I'm not sure. But you know, he is this cheap strategist, so I have to, it's just the way it goes. So anyway, oh crap. Okay, so there's our agenda. Start with some bad jokes or something. I don't know. Do you have any jokes, Jeff?
No, I didn't bring it.
Some history and a little bit about the current offering. Topic I like to call the candy store. You'll understand why. And then where we're going in terms of releases and features. And then, you know, in spite of our thunder being stolen completely, a very important part of this discussion, of this presentation, is a discussion with people who, you know, are going to buy this stuff. And we want to understand, we have some decisions to make about what kind of things to prioritize, and you know, want to hear about customer use cases. So that's a very important part of this project, or this presentation. So I guess the first thing I wanted to start with is a history of the project. And for that, I'm going to turn this over to John, who has actually been with the project, the UCX project, as it was originally called, back in the day, since the very beginning, since its conception.
Yeah.
So this slide. Yeah. There. Spill the beans.
Yeah. I was on an international relocation in Munich from 84 to 86, and I was coming back engineering in the US at the end of that tour of duty, and looking for a project to join. And the Ultrix group at the time wanted to set up the connectivity for VMS to be able to work with VMS. And they were forming a team with some funding that they had to go off and allow VMS to have access to the internet. So when I came back, we formed a small team that had like a single supervisor and 5 engineers. We had a guy who was working on UCP, you know, the control program. They had somebody working on FTP. They had a guy working on the network kernel itself, somebody working on the NFS server component, and then myself working on a set of exec system services that make VMS look like Unix. Okay, where you can access files, read directories, you know, do all the various type of operations that you would do on Unix, using file handles as input, you know, from the NFS server and whatnot. And we give back virtual channels and things like that. So our goal at that time for version 1 was just to produce a network that we could have a set of system, you know, a set of QIOs to be able to do network access, and to be able to have FTP and NFS. And that was what version 1 was being built for. And we started work, we had gone out to California, the product manager, supervisor, and 2 of us. And we ended up talking to the guys who eventually formed TGV, and talking to them just about, you know, what approach they used. And this was even before they formed their company and everything. And then we came back, we were doing our design, and we started in March of 87 to work on the code. And version 1 was released. We entered field test at the end of 88, and then probably released around June, I think it was. June of 89, maybe. So, and that was version 1. And it was hard to give that up because it was like, wait, just one more bug. I have one more bug I have to fix, And I got that. It's like, okay, can we build a kit? No, wait, I got one more bug. And this is what it was like. And eventually you learn that you got to let it go at some point in time. So I stayed on that project from that point, from 87. I left the company actually in 89, and they hired me back the next year as a contractor. Okay, in 90, and I stayed there as a contractor until 2005. And so I was 15 years doing contracting with them. And their problem was they never had headcount. They couldn't hire me back. So they were able to keep me on as a contractor. And by 2005, HP, in a typical way that they do things, when the stock price goes down, what they do is they just lay people off, and the first people to go are the contractors. And then when things get better again, they hire people back, and this is just the way they were doing things. So they let me go in 85, and I ended up out on the West Coast. And, I worked at Cray, I worked at Microsoft and storage companies, various things like that. So I ended up way out over there. Now, in the early days of UCX, we originally started, it was to be called The Bridge, was the name of the project originally. And we registered a device named VMS. That's where the BG device came from. It was supposed to be the bridge. And as we were going through and calling things the bridge and working on documentation and things, we discovered that there actually was another product out there that DEC had called the bridge. And it's now we had to change our name. So it became UCX, which was the Ultrix VMS connection, the U and the CX connection. So that's where our name came from. And years later, we ended up changing that. At the time, I think it was later on when they also went through a name change for the versions of Unix. I think they went from digital Unix to true 64 Unix. So we at the time then changed to TCP/IP services. And we had to go through and overhaul the whole product, and change all the names and the references to UCX out of there, and then leave components behind that still, like, you could still type in UCX for the command, so the old thing still worked and everything. We were adding new features to, all through the years. When it came time to do the alpha port in the beginning of the 90s, I'm the one who actually did that port, and somebody else did the Itanium port, but I did the alpha port, the original alpha port. And I remember ripping through that stuff, trying to get everything up and cobbling the pieces together with tools, because we were given early sets of tools to be able to do some of this stuff. We didn't have a simulator or anything. We had early hardware. And sometimes we were given hardware that was like, well, we've used this hardware. We have newer, faster stuff. So you could have this here. You could use this. And, it was, there were things we had to do. We had a lot of code written in C. And even from the backstage, we had a lot of code written in C. And at that time, there were no kernel routines you can call with a C interface. So you had to create these little stubs that could do, you call them with a call S, and they turn around and do a JSB to the routine and take R3 and R5 and return them as, two values in your argument list and stuff. So you cobble pieces like that together. But it was really a lot of work we tried to do and keep in C. And at the time, the True 64 team, they were looking at OSF. So OSF1 was being put together at the time, and the engineering team there was going to contribute the network layer and the memory management subsystem to OSF1. So in a side contract, I did all the testing of the memory management system for OSF1, but back on UCX again, there were other pieces that had to be added to the product, and and so on. So we were adding things like we didn't have a telnet, so we got to add a telnet, and it's like for, for the best performance we can get, we had to write that in macro. Because that also had some special JSP interfaces to call into the class driver, and so went ahead and implemented that, and a lot of the pieces that were in the bigger layers you would of course write in C, and they just put a couple of those. I usually had a VMS int.mar file, and those had the VMS interfaces to do the call list to JSP. We do performance analysis. We were being handed down. It was really funny because a lot of the machines we had were like VMS prototype machines that were given to us because we had a very small budget. Our budget, we were in the Unix team, and it's like, why would the Unix team want to spend so much money on VMS stuff when they want to spend it on their own product? So we were given a small budget, and we were working with hand-me-down hardware and stuff. At one point, we had a 782, which was a multiprocessor for VMS, but it wasn't SMP, it was ASMP. Mm-hmm. And then we ended up with Proto 4, one of the prototype machines. I think that was a 785 maybe. We ended up with that, and we were getting hand-me-down hardware. The team was growing over time. I want to say that at one point we had 35 to 40 people on the team. We actually had a big test team and a support team, and we had then ended up with a couple of different supervisors and a real manager, and the team was growing. And the sales were actually, they were doing very, very well with sales of the product and stuff. And it was just, we were plagued with certain types of bugs in areas, and just trying to keep up with all of those going. The Itanium port then was done in the early 2000s, and by a guy by the name of Lee Tibbert. And that stuff, I tried really not to look too hard at it, because that stuff was a lot more difficult actually than the alpha one was to do that. And it was like, and then looking at, when you have a problem and you have to debug it now, and something crashes, and these are what the instructions look like, and you have to cross them to what the instructions, and then look at the code to get make sure that the code you put in there and the instructions are generated sort of kind of makes sense, that the compiler did something correctly. And so, eventually the team, I want to say, so I left in 2005, and around 2007, the team sort of kind of disappeared. It's around 2007. When?
I don't know, when did stuff go to India?
Around then?
Around then.
Yeah. So, and Mike and I had actually lost contact. Was at Microsoft for a period of time. And I left Microsoft, and then he didn't know where I was. And I'd see in the news, like, oh, they're porting VMS to, to x86, and oh, they're going to use TCP IP on the network. And I was like, oh, maybe I should get in touch with Jim and see if he needs some help. And I'm thinking to myself, I'm going to be so overworked. I just can't do it. And then I saw they made the decision to go with TCP. Where was it? Multinet. So you made the decision to go with that. So I thought, okay, I guess I'm off the hook, because I wouldn't know anything really about multinet.
Well, it's the BSD stack.
Yeah, it's true. So the whole BSD stack, the multinet got their stack from BSD as well, and ours came. We were sharing the code with Digital Unix, and what was really nice is we had a couple of top engineers in the team. Some of them had come from DECnet from before. And we had a woman who was involved with the IETF for IPv6. So we had an in doing all the IPv6 work, and then working with the other team. So we were going back and forth. And the eventual goal we were hoping is, we had sprinkled a lot of the code with ifdef VMS, for certain types of things. Like, we don't need to put a protection check in here. Let's ifdef it out. We don't have this built into our kernel. Let's get rid of that. So we were sharing the code, and hopefully it was going to go back to Digital Unix, and it never did. And then I left, and then, I found out that team had been disbanded. And so we essentially had no more source. This code had a dead end. Either we maintain it and move forward with doing all of this work, which would just be too difficult to do, or we could look at doing something else, finding another source for the code. So, and at the time when we took the BSD that Ultrix had, they were working with Sun on some of the stuff, and they were working with Berkeley on some of the stuff. And the FreeBSD group ended up getting some of theirs from the base BSD that, you know, a distant relative of the BSD that a lot of other people got, the one that we had. And so nowadays, you know, we're looking at, okay, we want to put IPsec on here. We want to add some more features. We will pick up bug fixes. Where could we possibly pick some of this stuff up? Oh, no, by the way, you know, customers would like to have NFS v4. One of the projects I did at the end of the 90s was I wanted to pick up, we only had NFS v2 support initially in UCS. So we wanted to pick up NFS v3. So what I did is I actually created a free BSD environment that runs threads in the VMS kernel. And what we do is we interact with the network kernel, you know, bypassing the QIOs and stuff. We called some internal entry points and for the sockets and everything. And then we have a way to go take those threads out of the kernel, you know, and bring them into a process and then execute certain things in the process and then go back into the kernel. And so we had that infrastructure for like the kernel threads. We had a whole bunch of things, you know, in there that supported what looked like the kernel, you know, the code. You could basically compile the C code, link it all together, just call the right entry points, and it thinks it's a thread, and it runs, and it sleeps properly, and wakes up, and signals back and forth. So with that infrastructure, if we wanted to have NFS v4, we could basically just do the same thing again with FreeBSD. Just do the current FreeBSD notion of what a thread looks like. It was different from the digital Unix version slightly, but we could do very much the same thing, and we can pull in then some of the, you know, like NFS v4 along with NFS v3, create a new server to do all of this work. And then we're thinking, you know, we want iSCSI, and there's an iSCSI stack actually on FreeBSD, and maybe we can actually pull that in and get that to work as well. You know, that would be awesome. And then, you know, we were thinking, what else could we pick up? We could pick up the latest code. It's an advantage. I mean, it's basically free. It's sitting there. So what we're looking to do now is just another port of the latest BSD base of code and to be able to use that. So very much like we did originally. Now, of course, the amount of code compared to what we had before, probably in the protocol engine, we only supported IP and TCP originally in the initial code. They added SCTP later on. We had SLIP that was in there. We had PPP that was in there.
You had UDP.
Yeah. What else? I think-
ICMP.
What's that?
ICMP.
Oh, you have to have that for TCP. Yeah. We had that ARP and some of those things, and those all come from that Ethernet, the Ethernet layer. But so all of that work was done. It had all the basic protocols. And nowadays, now we have more. There's a whole slew of more stuff that I'm trying to build and, you know, get going and trick to work on VMS. But it offers us, I think, another way forward, you know, with having a nice protocol engine and hopefully better performance. So we're going to change the way some of that stuff works. But so that's basically it. The team now, people stay in touch. Yeah, and everybody's, it's funny, probably 3/4 of the people are no longer software engineers. They're school teachers, they're therapists, they're, you know, there's a funny story. We had a woman who was a writer in the team, and she came in, she says, I'd like to speak with everybody in the conference. So we get in the conference room and she comes in and she says, you know, I'm leaving the company and I just wanted to tell you all before you hear from someone else. So she says, oh, wait, just a minute. I have to go get some stuff. And she leaves the room, and we're all sitting there, and Carl, with one of the guys there who had like no sense of humor, suddenly stands up and says, I'm back. You know, he'd shoot us all. But she came back and she gave us all gifts that had to do with our personalities or some joke or something we played on somebody, because we were always playing jokes. It was a fantastic team. But these people are all off doing other things now. So it was a really fantastic place to work, a fantastic project, a very profitable product, and I'm actually very happy to be working on it again. You know, seeing names and pulling a module up and seeing, you know, Ping's name or Robert's name and saying, oh, I haven't talked to him in a while. Take the phone out and give him a call. So
Are you done?
All right, I'm done.
So, well, the only problem is he's not done. You can get up and talk more, but we've sort of advanced into the other topics rather than
Yeah.
just the history. So
It's a conspiracy.
it is. So, first I want to touch on, what was out to motivate why we would adopt FreeBSD for this project. But, here's our starting point. We did not get these components from HP. That's the biggest problem that I think we faced. And honestly, I suppose if we had, we might not even be talking here, but doing something different. But those are, to me, those are big holes for what should be in stack. For some reason, the arrow buttons don't make sense to me. And then there was the minor detour with this 10 point TCP IP 10.5. That was basically made a deal with process software to get multi-net from them, and basically rebranded it. And then I know who named it 10.5. I don't know why.
Wasn't me.
No, there's nobody around. Nobody left in the company that will own up to it. So, and actually, from a clean slate networking perspective, it wasn't a bad stack, although we jokingly call it that.
We call it
Those were the-
stat stack.
We call it sad stack, we call it bad stack. But where it falls short actually is in terms of the user interface. The user interface is completely different. In places that we didn't do DCL like interfaces, they did. In places where we did DCL interfaces, they did. Management of the project, the product is completely different. It was just not really a good experience for the customers in terms of compatibility or day-to-day use even. So sorry about that. We have accomplished a lot of things with TCP/IP version 6. We've done some modernization and filling in some of the holes. First, not on the slide, we sent the SSH problem off to a team that ported OpenSSH. We've done, we brought bind up to date. We're 9.11.36 based. And that actually gets you DNSSEC. You don't have to wait for 7.04. You had that on your slide. It's not quite. We did essentially a report of NTP for 9.4.8, complete report. And the problem was when I started looking at that, it was, if you look at the change log, it was thousands and thousands of changes between the version we had and where they are now. And it was much easier to start from scratch, kind of like, the SSH team is going to report OpenSSH for now. So that kind of thing.
You basically take a snapshot of what it is today, or you apply other edits over time on the open source libraries.
I guess I'm not sure I understand.
Okay, so when you say a report,
So we got a fresh download from them, and we started from scratch in terms of, making it run on VMS.
what about a year from now? You get updates, edits from.
We haven't yet. That's something that that's probably a staff problem more than anything. It's something that once you neglect that for a while, the problem gets out of control, which is kind of where we are with the network stack, really, in terms of last update it received. And then we've been doing defect repair, trying to get update kits out on a 3 to 4 month basis. Everybody says, no, you don't have to do it that often. And it's like, I have fixes in front of me. I know customers want them. I want them out the door.
Mike, I'm going to make this, I mentioned this during Camille's session earlier, I'll mention it here for the record. The one area where update frequency needs to be a lot faster off the firing line is crypto changes and bug issues.
Okay.
And also when you're porting stuff, the Linux or Unix conventions for handling crypto libraries vary dramatically.
Yeah.
In the VMS world, we need the fact that they need to use a shareable.
So,
That can
yeah,
easily
to that
slot in.
subject, and
Happy to take it offline.
we can talk about that offline, but on that subject, there's actually OpenSSH code in the TCP/IP services in our source, and we've converted everything to use the shareable libraries so that we don't have to wait for.
Thank you.
If there's a bug in OpenSSL, we can pick it up without having to patch TCP/IP. For exactly this reason.
Oh, yeah, it's a nightmare telling security people that, yes, Windows issued the update, Linux issued the update, and that.
Yeah.
Don't want that.
So anyway, back to where we are on 6.0. Where we'd like to be is, well, there's still the missing hole of IPsec. I don't know how popular that is with customers. I'd like to know how popular that is with customers, but I think it's a big hole. Especially when I know I could leverage that to secure things like DECnet over IP and clusters over IP traffic. It's something we should have. The other thing is kind of like the problem with NTP, looking at the progress in terms of RFCs that apply to the core protocol code. We're talking 10 to 15 years worth of changes. And I actually looked at this one of two ways. I'd start with the latest RFCs and work back a little. Does this apply to us? Should we have this? Should we have? Oh, you get about 5, 10 into it, and you go, oh, we need all this stuff. That's just all there is to it. And the other end of it is you start from when I know we picked up our last update of source, which was in 2005-ish, and you can work it forward and say, yeah, do we want this? Do we want this? And it's like, same thing as at the other end. It's like, oh, no, we want all this. I don't need to read through all these things. So what we really want to do is jump to a modern stack. The other thing that's would not be nice is to be able to launch some of these projects without the overhead, the enormous amount of work that it is to start them from scratch. If you wanted to do NFSv4, that's quite an undertaking. So we want options, basically. So obvious. Oh, steal. Oh, no, wait a minute. It's adopt a stack. It's not stealing. It says it right there in the license. We can do whatever we want with it. I tried to make. I'm not a PowerPoint guy. What I really wanted to do was have that without having to touch it again. Just be up there, flash, and then switch to adopt. But maybe next time.
In-slide transition.
I know exactly what it is. I don't know how to do it, and I don't need to be told that. But thank you. Anyway, so what do we get? You get the power of open source development. That's the bottom line. Contemporary BSD stack that turns out to be very compatible with our source overall, and is actually getting continued development by a project with a long history of cranking out releases. widely tested, maintained, security updates, new features. So the candy store. This is basically, so I would be perfectly happy. If all I got was this stuff, okay? You know, a current stack, skip 15 years of RFCs, you know, some interesting stuff, but as we started wading through the code, we have, look at there, we have IPsec, it's all done. Okay. Oh, and they've slipped in WireGuard too. It's a no-brainer. Crypto is actually in the kernel. Your issue around crypto updates may be a good question for the kernel code, but we will fix that too. Don't stop. Yep, that's it.
Agreed.
Okay. So this is basically a laundry list of all the fun we find in the FreeBSD stack. We got packet filters, you know, a real firewall. TCP/IP services has a list of, you can configure services to have an allow, deny type thing, but it's got a limited number of entries that you can add to it. These do not, and these are, so IPFW is the FreeBSD. I think they originally started with what was the stack that Darren Reed did? IPF? I don't know. They started with a different. They eventually wrote IPFW. PF comes from the OpenBSD group. It is an extremely popular stack. It's a packet filter that's been ported pretty much everywhere. Anybody that's seen it said, "Oh, they got to have that." Although I think I saw that NetBSD was going to abandon that. Other things we noticed, you get NAT that's comes with is implemented with the packet filters. Alt Q is something that is also exposed by the packet filters. That's a alternative outbound queuing mechanisms for bandwidth management. And the list just gets even better. iSCSI is in there. CAM, actually, FreeBSD storage is with CAM, something that VMS never did. I'm not quite sure why. But iSCSI, it turns out, is a CAM SIM driver. CAM comes in, the architecture is basically peripheral drivers up on the top, which is like VMS class drivers. And they all talk through a central component called XPT, who funnels stuff down to the equivalent of VMS port drivers, which are called SIMs. iSCSI is actually a CAM SIM. And I'll get back to that. Some interesting stuff about CAM. Oh, also NFS v4 implementation and SMB as well. So we could actually do Samba in the kernel. We so inclined. A couple more Netlink. That's a management configuration API. OFED. It's a framework for RDMA. Netcraft. What the heck is Netcraft? John told me to put Netcraft.
Yeah, NetGraph. So it's another it's a facility for supporting routers.
Okay.
Supporting different routing protocols.
So hence the candy store. It's like, I wanted to update.
You want everything.
I wanted to get our stack more compliant. Maybe even some compatibility, New Hampshire, University of New Hampshire compatibility test lab. We should send that and actually get get something. Anyway, so how are we gonna roll this stuff out? First thing, this is the priorities of the team. Okay, and I feel like I need to mention this, and it's prioritized in this order. Broken customer use cases is number one. So if something big comes in, sometimes it involves dragging John away from it, somebody else, and that's why we're not a what do you have 7,000 UCX engineers, something like that.
7,000.
7,000. I don't know. It was a lot.
Yeah, we had a lot.
We got a couple. So anyway, customer use cases, security issues, and then of course the union of customer reported security. It would be higher up. And then and when we after that's covered, then we can spend cycles on compatibility, modernization, and finally performance. Performance is I think it's something that we know we to take a look at. A lot of people want to put that off until we have optimized compilers producing the whole system. I don't think that's unreasonable, but we probably we're gonna tackle modernization issues first, Billy.
Yeah, that stack has support for a lot of the offloads on the cards. The interface that we have between our code and the device doesn't support that yet. So that's got to be added into that layer.
So we need to figure out what kinds of offload mechanisms are offered on hypervisor.
That's right. Exactly.
Because if something isn't offered, then it
Yeah,
doesn't really make sense for us to spend cycles on that.
Or we could come around to bare metal. Well,
I would make an observation that the question is not what is offered by hypervisors presently. If it's in the roadmap for the various hypervisors, as a customer, I'd suggest putting it in preemptively rather than being in a tail chase.
okay, so let's go back to that. So time is flying along. So project priorities. The previously kernel update, and this is basically so our architecture is coming from UCX, either socket calls which get turned into QIOs or directly with QIOs. You enter a layer which translates those into basically the calls to the C routines that every BSD based stack has and operates on. And then there's that middle piece, the core thing that we're out to update. And then underneath that is BCI, which is the interface to the LAN subsystem layer, which sits underneath. So we're about replacing that middle chunk, which is substantial. Next is iSCSI initiator. We've been talking actually about updating our source for a couple of years. It seems like a year and a half at least, and iSCSI, I noticed that ages ago. And that was like, hey, we could do iSCSI, and nobody, 6 months ago, nobody was interested. Now we are. So NFS V4, we're going to get to that. And then we're going to make some improvements to mail crypto authentication. I wanted to hear about SCI's SMTP use cases, if there are any. Okay. And then performance and converting macro to C. We don't have an enormous amount of macro, but in terms of improving the maintainability of the code, and also it's much easier to find people that know C than it is to find people that know macro 32.
it seems a bit easier to optimize it, but also
That's right.
engage in the performance as well.
So TCP, what are we gonna do with TCP IP6? We're gonna, the macro conversions are gonna apply to that as well. At some point, we're gonna go to defect repair only, as 7.0 becomes available. At the moment, you do not get DHCP server. We question the need for that, given that you can get the DHCP server in your, actually in your hypervisor, for example. You can get it in a small box that's, you know, dirt cheap. People don't run big systems to run DHCP servers, but you know, if you have a DHCP server use case, we'd like to hear about it. But certainly, it's not going to show up in 6.0 or 6.x screen. Getting past bind 9.11 is also difficult due to constraints in our compiler support. It's either, yeah, that's just the reality. Okay, so 7x macro conversions start with the core FreeBSD kernel bits, the part that implements the stack, plus the bare minimum that it takes to make that useful. Performance assessments and improvements, follow up with a 7.1, which, you know, adds in some additional stuff. We're about the customer input here. Okay, 6.0, here's the detailed 6.0 list, kernel update. 7.0, yes, thank you. We need to go to syscontrol because the stack code uses that instead of our system-big infrastructure. And iSCSI, and that's it. We may start to look at performance. Depends on where 7.0 lands relative to natively built, you know, full OpenVMS systems. So this is 7.1. This is what we think is interesting next at the moment. I have some questions about WireGuard versus IPsec. I know right where the hooks are in the TCP stack for IPsec. I know it can secure clusters over IP, DECnet over IP because of where it is in the system. I haven't yet looked at the WireGuard kernel work that has been added to FreeBSD kernel, so I'm not exactly sure that. I don't know if I can accomplish the same thing. If I can, that might take the pressure off of the need for IPsec. If you can't, then you know, we need to proceed with IPsec. And then continue performance work. I mentioned both of these earlier, and I haven't covered them yet, so I'm sure some might be wondering, well, when are we going to get that stuff? Don't know yet. It's going to, so for NFSv4, we have the server side in the kernel to flush out the implementation. We need to either make our client speak NFSv4 or we need to start from scratch. And we have not really looked at that in much detail. We've got other things on the list of things to do. Encryption and authentication in SMTP, have a resource identified for that. I hope it's available soon. And that can work asynchronously to this other work. So, you know, it depending on the timing of when the person can work on that, that could show up in 7.0. Maybe not. We just don't know yet. So, so this is the This is a list of stuff we want feedback on, actually. MS Kerberos support. Does anybody have any interest in that? This is supposed to be interactive. We're supposed to, yes, or don't waste your time. Here's my laptop, just me to write it down. Does anybody have any feedback on that? No? That's a favorite of yours, though, isn't it?
Yeah.
See, he loves Kerberos, so. It may just show up there by accident, right?
Maybe some documentation on what it means.
Okay. It's secure authentication and transport for.
But you
NFS,
have
basically.
Acme on login.
Right.
So you have single sign-on effectively across a domain
Right, so, but
and carrying that forward.
we can do that, but, you know, some people think that they want Kerberos instead. That's what I'm trying to understand. So anyway, no big interest in that.
Yeah, the other one here is VMS is a SCSI target.
The question there becomes VMS to VMS, do you want to do iSCSI or do you want to do MSCP serve? The question also, another related question is, my recollection is last time iSCSI was attempted, the problem was at what point was it available during Bootstrap?
Mhm.
So the question, I repeat that question for the record. At what point will iSCSI be available?
Initiator or target?
Initiator.
Initiator, it's intended to be, you know, so you can, you know, from the get-go, just like clusters over IP. It was starting very early in the startup process. There's some hooks to.
But you can't, but early in the startup process does not mean boot from. I'm being very careful, Mike, what I'm asking.
Because we always boot from a memory disk on x86. That becomes a matter of the
Okay.
boot manager, not with TCP.
Fine, but you know where I'm going with this. Because a lot of low-end enterprise arrays are now coming out with iSCSI as the cheaper configuration. Even ones that are dual capable, the iSCSI is the cheaper one.
And they, you know, if you compare it like to MSCP, if there's a way for us to get OFED on there, we can get RDMA, we can get really good performance.
Yes.
You're there.
You see the direction I'm going.
Yeah.
I could also potentially see iSCSI might have some interesting implications if you were to do things like LD driver or LN driver and generating containers to run backups into over the network. So
Yes.
there might be an interesting use case around logical containers and iSCSI to them backups or things.
So we have a question, why would you need, if iSCSI gives you a normal mountable volume, say a DI, so just picking random names, if it gives you a DI volume, why do you need that?
You might, because you might want to be chucking different systems to different containers.
That's fine.
Yeah.
DI. A container is not semantically useful.
I've got to think about it more. It's just, it was something that triggered in my mind as a
All right.
possible use case.
I made note of that. Let's not spend too much time. We're gonna get tossed out of here. Bouncers will come for us. Yeah. IPv6 completeness, how important is that to people?
Don't need client, don't need DHCP. We're hard code everything.
Okay, so DHCP client, so we actually had a customer request for that, so. We do the, whatever the protocol is for auto configuring IPv6. But they were in an environment where they were told they had to use DHCP to get their connection. But sounds like nobody else is.
No. One more.
Oh, that's okay.
The problem is IPv6 is one of those creeping things on you. This it's coming slowly. You don't quite know when it's suddenly going to hit.
Yeah, that's.
It's becoming slowly for, is it 2 decades?
So the problem is there's the United States where IPv4 address spaces, you know, there's not as constrained as other parts of the world. So I have the concern of, environments where it's just mandatory to be present, so.
I don't understand the second from the bottom, static versus dynamic configuration.
So, IPsec comes with, so the pieces of it are, the crypto and the, engine,
Negotiation.
no, the engine that acts, uses the crypto to act on the packets. And then there's, the configuration of it, which is done via a PF key socket, okay? And the policy and the crypto requirements are pushed into the kernel by a small utility. I think it's IPsec CTL, but it's just, it knows how to speak PF key and you tell it the configuration, boom, you're done. The next step is a key exchange daemon where it's completely, all that stuff is negotiated between the key exchange daemon on the other end of a secure connection. And it's,
That was, I think this question makes sense. That's what I can do too.
what's that?
That would include like two.
Okay, that's getting IP2 is with the dynamic configuration that you need a key exchange daemon. You can do, well, what you will reasonably secure, stuff on your LAN, maybe with shared keys with just the utility. For some use cases, that's not good enough. Trying to understand if we want to spend cycles on, a key exchange daemon. And, that's the other thing. If you're coming from HP's implementation, the old protocol, ISACAMP, would be a requirement. So if there's anybody that needs ISACAMP compatibility, we need to hear about it. Yeah,
Yeah, so certainly for our requirements, we need the dynamic, as we said.
you do. Okay. I skipped. Where'd it go? If WireGuard could satisfy the requirements, is that preferred? Okay. So,
We want IPsec, we want IPv2. Really want GRE.
okay. Okay, thank you. Okay, then there's, completely random stuff thrown together on a slide. We've talked about,
1 minute left.
well, I will run 2 minutes over, just like
What else?
Bob did. That's where I'm getting my time, my rationalization.
That's why you left.
Oh, you didn't want to get. Okay, so all of our socket calls turn into QIOs ultimately, and we've talked about adding, developing system service like interfaces to do directly to the stack without involving QIO. I don't know. I guess the question I have is, how many people do QIOs to do network operations versus?
I'm representing A and B,
Okay,
so
Very
all our customers will be under that umbrella. Yeah, we've done that for.
okay. So if we did that and maintain both interfaces, that would be vastly preferable.
Sure, I'm assuming the system service would be with less overhead.
That is our hope.
LLDP is a yes for me.
Okay.
We go from apples to apples, we have conversion comparisons.
Yes.
All right. LLDP, yes. Does anybody need 4.3 compatibility? What I noticed is my first perusal of the FreeBSD code is there used to be a compat_4.3 compile time conditional which was completely gone in the new source. So I don't know if that's unconditional or it's gone. So anybody not can't survive with just 4.4? Okay. Alrighty, let's see. Oh, virtual NICs. Anybody's interested in that? So this is an interesting one paired with the routing. The idea would be to, as an HA solution, have a system with a virtual NIC and a routing daemon, speaking to two other networks and distributing the path to the virtual NIC's address to get, the connectivity problem solved with routing rather than other things.
Related idea there.
What's that?
A related idea. I assume that the standby IP is code red to the stack. So it's not even the
What's that?
The standby IP capability in VMS.
Oh, yes, that's not part of this.
That's just something that you had listen on standby IP. Should be up to that would actually solve a lot of HA problems for us.
Okay.
I prefer IPFW for that version.
IPFW over PF.
Mostly because I'm familiar with it.
Anybody else have I mean, they're gonna do similar things. The syntax is gonna be a little different. It's not that different. Okay, NAT you're gonna get for free when we put in any packet filter there. Does anybody need SLIP or PPP interfaces? No, that's my reaction too, okay, but we gotta have. What's that?
Back to the 80s.
Yeah. Let's see, what else? Management folder.
See, anybody missing anything? There are things you'd like to see in the product.
I was curious about your DSCLI's more utilities. I don't think it matters to me.
I wouldn't waste your time. Anyone who knows the utilities from other systems knows what it's like.
Okay. Well, I think all of them should be both, honestly. But we have only so many developer cycles to apply to the problem, so.
We're trying to appeal to younger people. You need Bluetooth in there. You can say it.
Okay, that's it. We're leaving the room.
All right, on that note, anybody else have any stuff they wanna? No, give me.
I was going to ask a question. It relates back to physical versus virtual things. Has anyone thought about whether something like IOV is supported in the end? Because that exposes a physical nick.
That would be the OFED stuff around that. So it depends. FreeBSD's got the support for that, but there's, in addition to having access to the device, the device ownership and being able to touch the device, you have to have the underlying memory lockdown and mapping and stuff like that.
They look like the physical hardware as well.
Yeah, it's a reduced feature interface. Like you can't do control type functions on the thing. You can do programs.
The very fast.
Yeah.
People get.
Sweet. Oh, yeah, we apologize for any jokes, puns, ramblings. We love our story. That's the other thing. The public roadmap is a final word on what we're confident about at the moment. The other stuff that's on the public roadmap, we'll get to it, but no commitment. Thank you.
Okay.